Another important session, dear students, is the inverse of a matrix which have the vital role in entire matrix, and it has also wide application to solve the linear equations. Is the inverse of a matrix. How can you find the inverse of matrix? Inverse of matrix हम कैसे निकालेंगे? So what is inverse of matrix? So अभी हम डिस्कस करेंगे. Now I will teach you about the inverse of a matrix. So what is the inverse of matrix? Now the definition of inverse of matrix. Before the definition, I want to say about the number system. Suppose x and y are two numbers, such that x into y is equal to 1. Suppose x and y two numbers say, and x into y is equal to 1. Now y is equal to 1 by x means x inverse. So if x into y is equal to 1, then y is inverse of x. Similarly, y is inverse of x is also inverse of y. So if the product of two numbers is 1, then 1 is the multiplicative inverse. Inverse means multiplicative inverse of another. Similarly, how can you find the inverse of a matrix? Look at here. A and B be two square matrices of same order. A, B दोनों square matrices with same order, such that they satisfy this condition. A into B is equal to B into A is equal to I, the unit matrix of order same as A and B. A and B का order जितना है, I जो है आइडेंटिटी मैट्रिक्स और यूनिट मैट्रिक्स, इसका भी ऑर्डर उतना ही है. A, B, I, these three are square matrices of same order. So if A into B is equal to I, B into A is equal to I. Look at here, x into y is equal to 1. Y is the inverse of x. Here the role of 1 is I. The identity matrix plays the role of 1 as in numbers. Number system में 1 का role here is played by the unit matrix. So if A into B is equal to I, if A into B is equal to I, then B is inverse of A. So we say B matrix is inverse of A, and also A is inverse of B. So if A into B is equal to B into A is equal to I, then 1 is inverse of other. A is inverse of B, B is inverse of A. And another thing is invertible matrix. What is invertible matrix? Invertible matrix. Invertible matrix means, suppose A is a matrix. If A inverse exists, then it is invertible matrix. Invertible matrix means the inverse of a matrix exists. If inverse of a matrix exists, then that matrix is known as invertible matrix. Invertible means inverse exists. So inverse exists. If inverse exists, then it must be square matrix. If a matrix is not square, the inverse cannot exist. The inverse cannot be found. If it is a rectangular matrix, the inverse of a rectangular matrix does not exist. The inverse of a rectangular matrix, suppose a matrix has order 2 cross 3, 2 rows 3 columns. Rectangular matrix, square matrix नहीं है. अगर मैट्रिक्स रेक्टेंगुलर हो गया तो इनवर्स डज नॉट एग्जिस्ट. द इनवर्स ऑफ 2 cross 3 मैट्रिक्स डज नॉट एग्जिस्ट. द इनवर्स मे एग्जिस्ट ओनली इफ द मैट्रिक्स इज स्क्वायर, बट देयर इज नो सर्टेनिटी दैट द इनवर्स ऑफ एवरी मैट्रिक्स exists. The inverse of every square matrix exists. It is not sure, but if inverse exists, then it must be a square matrix. That means inverse of a square matrix exists, but not of all square matrix has inverse. And the inverse of those matrices exist which are invertible. Invertible means inverse of a matrix exists. If inverse exists, then it is invertible. And the square matrix may have inverse. All the square matrices may not have inverse. Now look at here. This is a matrix 2, 1, 5, 3, and another matrix 3, -1, -5, 2. And these two are square matrices of same order, 2 cross 2. If we multiply these two, you may test it. This will be 1, 0, 0, 1. So now what happens? The product of two matrices is the unity matrix. Suppose this is A and this is B. Now A into B is equal to I. If A into B is equal to I, then one is the inverse of other. So here we can say A inverse is equal to B, as the product of two matrices, product of two square matrices is identity matrix. One very important question is the uniqueness of inverse. If the inverse of a matrix, if exists, is unique. Uniqueness of inverse means a inverse of a matrix may exist or may not exist. If exists, then it is unique. That means the inverse of a matrix has only one inverse. The inverse of a matrix is only one. A matrix may have only one inverse. कोई भी मैट्रिक्स का more than one inverse matrix नहीं मिलेगा. No matrix can have more than one inverse matrices. If the inverse of a matrix exists, then it must be one, only one. That is the uniqueness. How can we show? Suppose this will be proved by method of contradiction. Method of contradiction means, suppose B and C, there are two different inverse matrices of A. We want to show A has only one inverse. Suppose B एक inverse है, C भी एक inverse है. B is one inverse, C is one inverse. That means suppose A has two different inverses. Two different inverses. If B is inverse, then A into B is equal to B into A is equal to I. If B is inverse, then A into B is equal to B into A is equal to I, according to definition. Also, C is inverse. If C is inverse, then also A into C is equal to C into A is equal to I, because C is also inverse. This is the condition of inverse. Now what happens? But C, a matrix C can be written as C into I. Any matrix when multiplied with unit matrix is same. C is equal to Ci, and this is equal to C into the unit matrix I can be written as here A into B, which is equal to matrix multiplication is the distributive. C into AB can be CA into B, but C into A, look at here, C into A is I, so this is equal to I into B, but I into B is equal to B, which implies C is equal to B. But we have taken C and B, B and C are different. B and C are different, but here you find B is equal to C. So this is contradiction, means false. So this is contradiction. Contradiction means what we have taken is false. What we have taken, हम क्या लिए थे? B and C are two inverse. If this is false, that means A has not two different inverses. That means A has only one inverse. So it is proved that any matrix, if its inverse exists, then is unique. That means inverse of a matrix is always one. That is the uniqueness of inverse. Now, one very important question for exam is if A and B are two invertible matrices. Suppose A and B has inverse exists. A and B are invertible means the inverse exists. If the inverse of two matrices exist, then show that inverse of A into B, inverse of product, inverse of A into B is equal to B inverse into A inverse. How can we prove this? Suppose A and B be two invertible matrices. Suppose A and B has inverse or invertible. Now take A into B into B inverse into A inverse. I want to find this value, AB into B inverse into A inverse. Now look at here, AB into B inverse into A inverse can be written as A into B inverse into A inverse. Why? Suppose this is A, this is B, this is C. AB into C is equal to A into BC. Associative property. Matrix multiplication is associative. Now A into BC, which is equal to A into, again look at here, this is A, this is B, C, A, B, C. A into BC is equal to, A into BC is equal to AB into C. A into BC is equal to AB into C, which is equal to A into, but B into B inverse. A matrix when multiplied with its inverse is identity matrix. So this is I into A inverse, which is equal to A into any matrix when multiplied with identity matrix is the given matrix. A into I is A, so is A inverse, and A into A inverse is identity matrix. A into A inverse, any matrix when multiplied with inverse is the unity matrix. Now look at here, A into B, the product of two matrices is I. You know, if A into B is equal to I, then B is equal to A inverse. If two matrices are multiplied to give unity matrix, then one is inverse of other. So this property A into B is equal to I, A into B is equal to I, then what happens? One is inverse of other. So inverse, which implies inverse of AB is equal to B inverse into A inverse. Look at here, this is A, this is B. A into B is equal to I, A into B is equal to I. So A inverse is equal to B, that means inverse of this is equal to this. That means inverse of AB is equal to B inverse into A inverse. So it's proved. Very important question. Now, one of the important question for annual exam, which is a long question, or it may come in also in form of short question, which is the inverse of a matrix. How can we find the inverse of a matrix? The inverse of a matrix can be obtained. The first condition is that the matrix should be square matrix. I have already said in the previous class. If the matrix is rectangular matrix of order where M is not equal to N, the number of rows and columns are not equal, then the inverse doesn't exist. So if the square matrix A whose inverse exists, then how can we find the inverse of a matrix? हम अभी देखेंगे एक मैट्रिक्स का इन्वर्स कैसे हम निकालेंगे. बट फर्स्ट कंडीशन इज द मैट्रिक्स शुड बी स्क्वायर मैट्रिक्स. अगर स्क्वायर मैट्रिक्स होगा तो इसका इन्वर्स निकाल सकते हैं इफ एग्जिस्ट्स. सो कैसे हम निकालेंगे एक स्क्वायर मैट्रिक्स का इन्वर्स? सो इज इन्वर्स ऑफ ए मैट्रिक्स. नाउ लेट ए बी ए स्क्वायर मैट्रिक्स. ए बी ए स्क्वायर मैट्रिक्स of order n. A का order n means number of rows n, number of columns भी n, number of rows n, number of columns l, such that A inverse exists. A is a matrix whose inverse exists. Suppose A एक ऐसा matrix है जिसका inverse exist करता है, and In be the unity matrix of order n, the identity matrix. You know. Now, in order to find the inverse of a matrix, there are two ways. By applying elementary ऑपरेशन और एलिमेंट्री ट्रांसफॉर्मेशन अप्लाई करके हम ए इनवर्स निकाल सकते हैं. बट एलिमेंट्री ऑपरेशन इज ऑफ टू टाइप्स का एलिमेंट्री ऑपरेशन है. क्या? एलिमेंट्री रो ऑपरेशन, एलिमेंट्री कॉलम ऑपरेशन. सो वी कैन फाइंड द इनवर्स बाय अप्लाइंग आइदर एलिमेंट्री रो ऑपरेशन और एलिमेंट्री कॉलम ऑपरेशन. एलिमेंट्री रो ऑपरेशन अप्लाई करके ए इनवर्स निकाल सकते और एलिमेंट्री कॉलम ऑपरेशन भी अप्लाई करके इनवर्स हम निकाल सकेंगे. सो व्हाट इज द डिफरेंस, व्हाट इज द मेथड, व्हाट इज द प्रोसीजर टू फॉलो टू फाइंड द इनवर्स ऑफ ए मैट्रिक्स? लुक एट हियर, दिस इज एलिमेंट्री रो ऑपरेशन. इन केस ऑफ एलिमेंट्री रो ऑपरेशन you have to take A is equal to IA. A is equal to the unit matrix into A. And in case of column matrix, I am comparing. In case of elementary column operation, you have to take A is equal to AI. So most of the times the students are being confused about this IA and AI. I have seen the copies of many students. They are applying elementary row operation but taking A is equal to AI. Applying elementary column operation, taking A is equal to IA. Because there is a little bit confusion. But the students, A is equal to IA, A is equal to AI. Here is IA, here is AI. I am giving you a trick. Semi, row and column. Between these two, which comes first in general? In general, we pronounce row first. जब हम बोलते हैं रो कलम, ये टू वर्ड्स, तो ऐसे रो पहले आता है कि नहीं? सो याद रखना, जब पहले आता है आई वहीं रहता है. आई विल बी देयर व्हिच कम्स फर्स्ट. हाउ? दिस इज एलिमेंटरी रो ऑपरेशन. नाउ आई इज फर्स्ट and A is second. Here elementary column operation. Here A is first, I is second. Row first, I first. Column second, I second. In case of row operation, I comes first. In case of column operation, I comes second. So this is the trick, because you may confuse to apply this. So in case of elementary row operation, take A is equal to I into A. In case of column operation, take A is equal to A into I. Now your aim is apply elementary row operation here, apply elementary column operation here. You apply any operation on the rows, here you apply any operation on the column. Any operation means elementary column operation on the columns. But remember one thing, you have to apply elementary row operation in the matrix A and I. This A will remain same. इसका कुछ चेंज नहीं होगा. You can't apply here. And in this case, you have to apply elementary column operation in matrix A and I, not in A. That means you have to apply elementary operation, elementary row operation on A and I, keeping this unchanged. ये चेंज नहीं होगा. Don't apply any operation in this A matrix, and here apply elementary column operation on A and I, not on A. This will remain same, unchanged. So one thing in these two is the A matrix on RHS. The A matrix on RHS will be same. No operation will be applied on this matrix. You will apply any operation on AI. So one important thing is, when you are applying either elementary row operation or elementary column operation, keep this A on RHS constant. ये जो अप्लाई करेंगे एलिमेंटरी रो ऑपरेशन, हियर राइट साइड में जो ए है, ए मैट्रिक्स पर कोई भी ऑपरेशन अप्लाई नहीं होगा. एंड इन केस ऑफ हियर, ये जो राइट साइड में जो ए है, कोई भी कलम ऑपरेशन ए मैट्रिक्स पर अप्लाई नहीं करेंगे. हम अप्लाई करेंगे ऑन ए आई एंड ए आई. ये जो ए मैट्रिक्स राइट साइड में, ये मैट्रिक्स पर हम कोई भी ऑपरेशन अप्लाई नहीं करेंगे. सो व्हाट टू डू? हम क्या करेंगे? वी हैव टू अप्लाई ऑपरेशन ऑन ए आई. सो हियर वी हैव टू अप्लाई एलिमेंटरी रो ऑपरेशन. एंड रिमेंबर, if you are applying a operation on first row of A, the same operation will be applied on first row of I. If any operation is applied on second row of A, then that same operation is applied on second row of I. If any operation you are applying on A, the same operation is applied on the same row of I. Any row, first row, second row, third row, any operation will be applied same as on two matrices A and I. तो इधर क्या होगा कि तुम फर्स्ट रो में जो ऑपरेशन अप्लाई करोगे, वही ऑपरेशन आई मैट्रिक्स का फर्स्ट रो में अप्लाई करोगे. ये मैट्रिक्स का सेकेंड रो में जो ऑपरेशन अप्लाई करोगे, आई मैट्रिक्स का सेकेंड रो में भी वही ऑपरेशन. तो मतलब ए का फर्स्ट रो, आई का फर्स्ट रो, you have to apply same operation on same row of A and I. And what here, इधर क्या करोगे, अगर A का फर्स्ट कॉलम में तुम चाहते हो कोई ऑपरेशन अप्लाई करने के लिए, A का फर्स्ट कॉलम में जो ऑपरेशन अप्लाई होगा I का फर्स्ट कॉलम में वही ऑपरेशन, A का सेकंड कॉलम में जो ऑपरेशन I का सेकंड कॉलम वही ऑपरेशन, एंड लाइक दिस. तो यू हैव टू अप्लाई same operation on A and I on the same rows of both A and I. You have to apply the same operation on A and I on the same columns. Same operation, same column. Same operation, same row. But A, B, same. Look at here. Same operation, AI. Same operation, same rows. Same operation, same columns. And this remains same. This is the funda. So you have to apply any operation. You can apply any operation, but the operation should be same on both and on same rows. So if you apply the elementary row operation, what is the aim? Your aim is to convert this matrix, transform this matrix to form unit matrix. Your aim is apply elementary row operation in such a way that this matrix will be transformed to I. Your aim is तुम ऐसे अप्लाई करो elementary row operation on this matrix such that ये A matrix ट्रांसफॉर्म होकर I आइडेंटिटी मैट्रिक्स हो जाएगा. तो जब ये आइडेंटिटी मैट्रिक्स हो जाएगा तो ये जो आइडेंटिटी मैट्रिक्स था ये भी चेंज हो जाएगा, क्योंकि इधर ऑपरेशन अप्लाई हुआ, इधर भी ऑपरेशन अप्लाई हुआ है. तो ये एम है, इसको आई करना है, इसको आइडेंटिटी मैट्रिक्स करना है. ये जब ट्रांसफॉर्म होके नया मैट्रिक्स हो गया, ये भी तो नया मैट्रिक्स हो जाएगा. सपोज द न्यू मैट्रिक्स व्हिच इज फॉर्म्ड आफ्टर elementary row operation, this I becomes B. Suppose the new matrix is B. A transformed to I transformed to suppose B. And A is same. There is no change of A. We are not applying. We haven't applied. We are not applying any operation here. So this A is same. Now look at here what happens. A transform to I transform to new matrix B, A is same. Now the product of these two matrices is I. If product of two matrices is unit matrix, then one is inverse of other. So here what happens? A into B is equal to I means A inverse is equal to B. So the matrix which appears here is the inverse of A. ये टू मैट्रिक्स का प्रोडक्ट आई हो गया, तो टू मैट्रिक्स का प्रोडक्ट जब यूनिट मैट्रिक्स होता है तो एक दूसरा का इनवर्स होता है. तो आई ए इनवर्स इज इक्वल टू बी. व्हाट हैपेंस हियर? यू आर अप्लाइंग एलिमेंटरी रो ऑपरेशन, बट हियर एलिमेंटरी कॉलम ऑपरेशन, बट द एम इज टू ट्रांसफॉर्म दिस मैट्रिक्स टू फॉर्म यूनिट मैट्रिक्स. You have to form this matrix to unit matrix means after applying elementary column operation, this will be transformed to I. Unit matrix हो जाएगा. This will be unit matrix. If this will be transformed to form unit matrix, then this I also be changed, because some operations are applied simultaneously on A and I. We are applying some elementary column operations on A and I. If A changed, then I must be changed. If A transformed, then I must be transformed. Suppose I is transformed to a new matrix B. Suppose I change होकर B हो गया. But this A same. No operation is applied on A. So is A. So if the product of two is I, then one is inverse of other. If the product of two मैट्रिक्स, दो मैट्रिक्स का प्रोडक्ट अगर यूनिट मैट्रिक्स हो जाए तो एक दूसरा का इनवर्स होता है. सो व्हाट हैपेंस हियर? A inverse is equal to B. So this is the process to find inverse either by elementary row operation or elementary column operation. The aim is take A is equal to IA, A is equal to AI. Convert this A to I. A को I बना दो तो आई चेंज होकर नया मैट्रिक्स हो जाएगा, वो जो नया मैट्रिक्स आएगा वो होगा ए का इनवर्स, and here is also same, but the thing is here you have to apply elementary row operation and here you have to apply elementary column operation. So this is the process to find the inverse of a matrix. Now is my mental math, the procedure what to be followed to find the inverse of a matrix by elementary operation. First is elementary row operation. Look at here, याद रखो ये trick, every problem can be solved easily. Now the first aim is you have to make this element a11 the element in first row first column, जो element first row का first column में है वो element को 1 बनाना है. So कैसे बनाएंगे? How can you make it 1? Look at here, if you are applying elementary row operation then this will be 1 with the help of these three elements. That means the elements in first column you are applying elementary row operation, this will be 1 but with the help of elements of first column you take this element with 2 और this with 1. जिसको 1 करना है वही एलिमेंट को तुम सेकेंड रो या थर्ड रो का एलिमेंट के साथ ऐसे एडजस्ट करो जैसे वो 1 बन जाए. हमारा एम इज टू मेक इट 1. सो इन एलिमेंटरी रो ऑपरेशन the first aim is to make this element 1 with the help of elements of first column. How? I will explain you. And in case of elementary column operation, when you are applying elementary column operation, you have to make this one because your aim is to make it unit matrix. Unit matrix means this. So in order to make it 1 by elementary row operation, convert this to 1 with the help of first column elements. In case of elementary column operation, if you want to convert this element to 1, then take the help of the elements of first row. रो ऑपरेशन में ये 1 होगा फर्स्ट कलम की एलिमेंट के साथ, ऐसे एडजस्ट करो ये 1 हो जाएगा. कलम ऑपरेशन में ये एलिमेंट 1 होगा फर्स्ट रो का एलिमेंट के लेकर. You have to change this element to 1 by the help of elements of first row. So how can you convert? Look at here. Suppose you find any 1 in the first column. If you find, then interchange. Now look at here. Here is 1. So you interchange these 2 rows. फर्स्ट रो थर्ड रो हो जाएगा, थर्ड रो फर्स्ट रो हो जाएगा. ये एक ऑपरेशन है, एलिमेंटरी ऑपरेशन का फर्स्ट प्रोसेस है. Any 2 rows can be interchanged. So if you find 1 in any row, then interchange these 2 rows. So this will be easily make to 1. So here is 1, you can interchange. But every time you can find 1. If 1 here also, this you can interchange. But suppose it is like this. How can you find? How can you convert this to 1? Now look at here. Here is 2. Here is 3. Now subtract row 1 minus row 2. 3 minus 2. This will be 1. And these elements will be changed. But this becomes 1. ये तो 1 हो जाएगा ना माइनस करने से. So anyhow, suppose here is 1. Here is 11. Here 3, here 2 subtract करेंगे 1 हो जाएगा. But here is 11. So क्या करेंगे? What shall to do? Now look at here. Here is 11. Here is 2. Now multiply 5 here. 5 into 10, 11 minus 10, 1. So multiply row, so convert row 1 को change कर दो, change row 1 by row 1 minus 5 into row 2. Multiply 5 here, subtract. So this will be 1. So the first thing is change this element to 1 with the help of first column elements. Here change this element to 1 by the first row elements. So the first step is over. Second is, anyhow you make this element 1. After changing this element to 1, ये जब 1 हो जाएगा, the next process is, ये जिसके सहायता से 1 हुआ था वो एलिमेंट को 0 करना है. The elements which are helping to form this element 1, those elements will be 0. That means you have to convert these 2 elements to 0. ये 2 elements को 0 करना है. कैसे? Now take the help of 1. ये दोनों के साथ ये 1 होगा, सो ये दोनों 0 होंगे with the help of 1. So take the help of 1 to make these two elements 0. And here, after changing this element to 1, make these two elements to 0. Here, these two elements to 0. After making 1, the first column element should be 0. And here, after making 1, the first row element should be 0. So then what to do? Suppose these two elements becomes 0. Next is you have to change the element in second row and second column. ये element को 1 करना है. कैसे करेंगे? With the help of here these two elements. ये 1 हुआ, ये 3 element के साथ. Now you have to change this element 1 with the help of these two elements. And here you have to change this element 1 with the help of this. Here column wise, here row wise. Here row operation, here column operation. Here row operation, here column operation. Here you are changing column wise, here row wise. Suppose this becomes 1 with the help of these two elements. With the help of these two elements, suppose this become 1. Then after changing it to 1, make this element to 0 with the help of 1. So this will be 0. And also change this. ये 1 हो जाने के बाद ये 2 elements को 0 करेंगे. And here when it is 1, then make these 2 to 0. And next is to change this element to 1. And if this becomes 1, when this becomes 1, then convert these two elements to 0 with the help of 1. So look at here. These two will be 0 with the help of 1. These two will be 0 with the help of 1. These two will be 0 with the help of 1. Here these two will be 0. ये 2 0 होंगे with this one. ये 2 0 होंगे with this one. And ये 2 0 होंगे with this one. This is the simple process to follow in both cases to find the inverse of a matrix. Now question here, if A is equal to 1 2 3 2 1 4 1 0 2, then find A inverse by elementary row operation. So is a given square matrix, we have to find the inverse. A inverse निकालना है by elementary row operation. And here solution is now A is equal to this matrix. So we have to take A is equal to IA. A is equal to IA, which implies A is equal to this matrix 1 2 3 2 1 4 1 0 2 is equal to I. I is the unit matrix whose order is same as A. एक order third order है, so this I is also third order unity matrix, means 1 0 0 0 1 0 0 0 1, and this A remains same in both operations. A on the right hand side always remains same. जो A मैट्रिक्स राइट हैंड साइड में रहेगा उसका कुछ चेंज नहीं होगा, वो ऐसे रहेगा. Now we have to apply elementary row operation. The first aim is to convert this element to 1, but this is already 1, so no necessity of changing this. Now if this is 1, the next thing is to make these two elements to 0. ये 1 होने के बाद ये 2 एलिमेंट्स को 0 करना है. तो ये जो 2 एलिमेंट्स 0 होंगे किसके साथ, किसके सहायता से? With the help of this one. That means we have to change row 2 and row 3. Now look at here. I want to change row 2 and row 3. How? कैसे चेंज करेंगे? Look at here. इसको अगर 0 करना है, if I want to make this 0 with this, so 1 minus 1 is 0. That means row 3 minus row 1. So I want to change row 3 as row 3 minus row 1. And how this can be 0? Look at here. Here is 1, multiply 2 and subtract here. Now row 2 is row 2 implies row 2 minus 2 into row 1. So these are the two operations will be applied. One on row 2, another on row 3. Row 2 means row 2 of A and I, I have already said any operation will be applied on same rows of both matrix. ये दोनों matrix का same row में apply होगा. So now look at here, row 1 change नहीं हुआ है, row 1 remains same. Now I write here A, row 1 remains same, 1 2 3, here is 1 0 0. Next is row 2 minus 2 row 1. So we have to multiply 2 on row 1 and subtract from row 2. row 1 में 2 मल्टीप्लाई करेंगे, जितना होगा row 2 से subtract करेंगे. So 2 मल्टीप्लाई करने से 2 into 1 2, 2 minus 2 0, 2 2 जा 4, 1 minus 4 minus 3, 2 3 जा 6, 4 minus 6 minus 2, 2 1 जा 2, 0 minus 2 minus 2, 2 0, 2 into 0 0, 1 minus 0 is 1, 2 into 0 0, 0 minus 0 is 0. Now row 3 minus row 1, row 3 minus row 1, 1 minus 1 0, 0 minus 2 minus 2, 2 minus 3 minus 1, 0 minus 1 minus 1, 0 minus 0 0, 1 minus 0 1. So here what happens, we get this after transformation. Now the second thing is, after these two elements becomes 0, ये 2 elements 0 होने के बाद सेकेंड रो का सेकेंड एलिमेंट जो है इसको 1 करना है. We have to make this 1, and with the help of these 2 elements, how I have to change second row. How? Row 2, we have to change this 2. Row 2 is equal to row 2 minus 2 into row 3. Multiply 2 on row 3 and subtract from row 2. So row 2 will be changed. Row 1 remains same. Now I write here is equal to row 1 remains same. Row 1 is 1 2 3, 1 0 0. Row 2 multiply here 2, row 3 into 2, and row 2 minus 2 into row 3. So 2 multiply करने से 2 into 0 0, 0 minus 0 is 0. 2 multiply करने से minus 4. So minus 2 into 2 minus 4, minus 3 minus, look at here, here is minus 3, minus row 2 minus 2 into this one means minus 4. So this is 1, plus 4 हो गया. Now here is multiply 2. If you multiply 2 here, this becomes minus 2. So minus 2 minus minus 2 plus 2, this is 0. And here is, if you multiply 2 here, this is minus 2. Minus 2 minus minus 2 is 0. If you multiply something 0, 1 minus 0 is 1. If you multiply 2, this is 2. 0 minus 2 is minus 2. And row 3 remains same. 0 minus 2 minus 1 minus 1 0 1. So next is, after this becomes 1, ये जब 1 हो गया तो ये 2 एलिमेंट्स को 0 करना है. किसके सहायता से? With the help of this, we have to make these 2 elements 0. How? Now these 2 elements will 0. In order to convert this 0, इसको अगर 0 करना है तो look at here, 2 multiply कर दो, 2 into 1 2, 2 minus 2 0. So row 1 minus 2 into row 2, and ये 0 होगा. ये कैसे? row 3 plus 2 into row 2. 2 multiply करो और इसके साथ ऐड कर दो, 2 multiply कर 2 हो जाएगा. So row 1 is changed as row 1 minus 2 row 2, and row 3 is row 3 plus 2 into row 2. So what happens? Look at here. Now this is the new matrix after this type of operation. ये ऑपरेशन करने के बाद हमको ये मैट्रिक्स मिला. Now look at here. First this is 1, these 2 elements 0. This is 1, these 2 are 0. Now we have to convert this element to 1. How? Now here is minus 1. Simply multiply minus 1, and any non-zero scalar can be multiplied. So row 3 implies row 3 into minus 1. Row 1 remains same. 1 minus 2 4 into A. Row 2 remains same. 0 1 0, 0 1 minus 2. Row 3 into minus 1. Minus 1 into 0 0, minus 1 into 0 0 is 1. Here is 1 minus 2 and 3. Now our aim is, If this is 1, then these two elements will be 0, but this is already 0, so this will be 1. That means we have to change row 1, and with this element this will be 0. इसको 0 करेंगे 1 के साथ. I again saying these two will be 0 with the help of 1, these two will be 0 with the help of 1, and these two with this. So now row 1 is row 1 minus 3 into row 3. Multiply 3 here, minus 3 minus 3 0. So we have to change row 1. कैसे? Here 3 multiply करेंगे, minus करेंगे. 3 into 0, 3 into row 3, 3 into 0, 0, 1 minus 0 is 1. 3 into 0, 0, 0 minus 0 is 0. 3 into 1, 3, 3 minus 3 is 0. And it's here 3 into 1, 3, 1 minus 3 is minus 2. 3 into 2 is 3 into minus 2 is minus 6. Is minus 6. Here is minus 2 minus minus 6 plus 6. This is 4. And here 3 into 3 is 9. 4 minus 9 is minus 5. Row 2 remains same. 0, 1, minus 2. Row 3 remains same. 1, minus 2, 3. Now, here what happens? This is I, and this is B, and this is A. I have already said, start from A is equal to IA, reach at I is equal to BA. And the new matrix in place of I is the A inverse. So I is here, the unit matrix is transformed to this. This is the new matrix which is formed in place of unit matrix, and this is A inverse, which implies A inverse is equal to this matrix minus 2, 4, minus 5, 0, 1, minus 2, 1, minus 2, 3. So this is the process to find the A inverse by elementary row operation. Now another question is, if A is equal to 2, 5, 1, 3, then find A inverse by elementary column operation. So if you want to apply column operation, then A is equal to this matrix, and you have to take A is equal to AI. In case of row operation is A is equal to IA. Here is A is equal to AI, and you have to reach at a place where A is equal to I is equal to AB. This will be I, and this will be new matrix. Now here A is equal to 2, 5, 1, 3. A in the RHS remains same. RHS में जो A matrix रहेगा उसका value change नहीं होगा. You have to operate only A in the LHS and I in the RHS. A into I is the unit matrix. Now our aim is to convert the element in first row first column to 1. इसको 1 करना है, ये element को 1 करना है. किसके साथ, किसके सहायता से? With the help of, I have already said, elementary column operation means make this one with the first row elements. That means with these two elements, arrange these two elements in such a way that this will be 1. How? Look at here. We have to convert this to 1. अगर इसको 1 करना है, here is 5. Now multiply 3 here. 3 into 2, 6. 6 minus 5 is 1. So 3 into column 1 minus column 2. So I change it as C1 column 1. Column 1 is equal, implies 3 into column 1. We multiply 3 here minus column 2. What happens? We multiply 3 in the column 1 and subtract column 2. So 3 multiply करने से, if we multiply 3 here, 3 into 2, 6. 6 minus 5 is 1. Here column 1 is 3 into column 1. 3 into 1, 3. 3 minus 3 is 0. And this column 2 remains same, is equal to A into, now I have already said, the operation which is applied in the first column of A, that operation will be applied in the first column of I. The same operation, same column in A and I. So here is also same operation. 3 into column 1 minus column 2. 3 into 1 is 3 minus 0. 3 into 1 is 3 minus 0 is 3. 3 into 0 is 0 minus 1 is minus 1. Column 2 remains same. So this becomes 1. Next our aim is to convert this element means this one to 0. इसको 0 करना है. ये 1 होगा, ये 0 होगा. कलम में, रो में ये 1 होगा, ये 0 होगा. बताया था. So you have to make this 1, but this will be 1 with the help of, sorry, this 5 will be 0 with the help of 1. इसको 0 करेंगे ये 1 के साथ. So how can you convert this 0? Now look at here. Here is 5. Here is 1. Multiply 5 here and subtract. That means we have to change column 2. Now column 2 is equal to column 2 minus 5 into column 1. This is column 2. This is column 1. Column 2 is equal to column 2 minus 5 into column 1. So we have to change only column 2. Column 2 will be changed. Column 1 remains same. Is equal to A into column 1 remains same. So only column 2 change होगा. Only to change column 2. How? Column 2 minus 5 into column 1. Here is column 2. Here we have to multiply 5. इधर 5 multiply करेंगे, यहाँ से minus करेंगे. So 5 into 1 5. 5 minus 5 is 0. 5 into 0 is 0. 3 minus 0 is 3. Here multiplying 5. 5 into 3 15. 0 minus 15 is minus 15. Multiply 5 here. 5 multiply करने से कितना होगा? If you multiply 5, this is minus 5. 1 minus minus 5 is 6. Now, next aim is to convert this element to 1. And the element in the last row and last column will be 1 simply by dividing that element. Now, we have to divide 3 in second column, not in row, because here we are applying elementary column operation. So column 2 will be changed as 1 by 3 into column 2. Column 3 into 1 by 3. That means we multiply 1 by 3. So column 1 remains same. A is same from first to last. Column 1 remains same. And we have to multiply 1 by 3. Multiply 1 by 3 means divide 3. 0 by 3 is 0. 3 by 3 is 1. Here minus 15 by 3 is minus 5. 6 by 3 is 2. Now this is I into A. Here is A. A becomes I. And I becomes new matrix. Suppose is B. Now A into B is I. Product of two matrices is I. If product of two matrix is I, then one is the inverse of other. So this B is inverse of A, which implies A inverse is equal to this matrix 3 minus 5 minus 1 2. So this is the process to find the inverse of a matrix. So dear students, inverse of a matrix is one of the important question and which comes in all exams. So dear students, if you are really enjoying my lessons, my teachings, please subscribe my channel for getting the latest updates. Thanks.